Hi everyone, I'm Shu from the chemistry department, and today I'm going to talk about the dark field microscope. So dark field microscope is based on the scattering of light. When light incident onto a sample, it can excite an electron from ground state onto a virtual state and then relax back to the ground state. In this process, the frequency may be slightly changed, but most importantly, the direction of the light is changed. So this scheme briefly describes what is going on in a bright field and a dark field microscope. Light that comes out of a lamp is focused by a condenser lens onto the sample holder. The light then goes through the sample and the transmitted light is collected by the objective lens, then the ocular lens, and then to the eyepiece. That's why the background of a bright field microscope is usually bright and the sample is shown as a dark spot. Well, in a dark field microscope, there is some difference. First of all, there is a light stop right in front of the light source. This stop blocks the central beam and only a ring of light is focused onto the sample. The red area indicates the propagation of the transmitted light, and the blue area indicates the scattered light. Only the scattered light is collected by the objective lens and goes through the eyepiece. But the transmitted light that is shown in the red is not collected and misses the lens. So the background in a dark field microscope is usually black, and only the samples can give rise to a bright spot. What we are looking right now is a real dark field microscope. This is actually a reflected dark field microscope. So the sample is placed on the sample holder, and the sample holder is on a stage that is operated by this stage control. The light source we use here is a tungsten halogen lamp. You can tune the intensity by tuning the input power. The light goes through mirrors and then goes onto a polarizer. This is where we put a polarizer. You can tune different angles of the polarizer, or you can remove it so the incident light is unpolarized. The light then goes through a rotating aperture controller where you can choose between bright field and dark field. Now we are looking at a dark field where we put a light stop on it. And if you tune it, it can be bright field. Then the condenser lens focuses the light onto the sample. You can tune focus by this coarse and fine adjustment. When the light hits the sample, the scattered light is collected by the objective lens. And the reflected light misses the lens and is not collected. Then the light goes to the ocular lens and the eyepiece, or you can choose for it to go to the CCD camera.